Hi everyone, how are you today? So you're welcome to today's class. We are continuing with calculus. Okay, so today in the previous lessons we've already covered 2 out of what was listed. So we did the differentiating, how to find the gradient, and today in this lesson we're going to look at 2 concepts: the equation of the tangent to a curve and also the equation of the normal to a curve. So by the end of this lesson you understand these 2 things, and they usually come in the exam. Okay, so to begin with, before we can look at the sample questions that are there, we are briefly going to explain what a tangent is. So we'll start with the equation of a tangent. So now, a tangent is simply a line that only touches one point of a curve. So for example, we can have a tangent. Maybe they say there's a point that has been drawn here. So as we draw the tangent here, we should make sure that that line should only touch one point of the graph. So that line there, which is only touching one point of the graph, then this one is a correct tangent. So it can be here, it can be here, as long as when you draw the line, it touches one point of the graph. So this is what we call the tangent. Okay? Then also, we are also going to deal with the normal. So for the normal, this is a line that is drawn perpendicular to the tangent. So when we draw a line here, which should be perpendicular to the tangent, what I mean by perpendicular is when we draw it like this, and then it will form a 90-degree angle. So this one is what we are going to call the normal. Okay, so a tangent is the line that touches only one point of the graph, then the normal is the line that is perpendicular to the tangent. So now, the relationship between these two is that when you multiply, so the tangent, when you find the gradient of this tangent, it will be called m1. Then the gradient of the normal will be called the m2. So the relationship between these two lines is that when you multiply the gradient of the tangent and the gradient of the normal, the product will be -1. So what I'm saying is m1 multiplied by m2, the answer should be -1. So that is the relationship between the normal and the tangent. Okay, so having that knowledge, let's now see how we can find the equation of the tangent. So we'll start with the tangent, we'll call it question 1. So this one here, sample 1, and this one will be number 2. So we'll start with our first one there. So solution, please follow the steps. They've been summarized such that you can be successful in your examinations without difficulties. Okay, so now find the equation of a tangent to the curve, and they've given us this curve here. So the first at the point x. So step number 1. Now let's follow the steps properly. So step number 1, you have to find y. Find the value of y. So step 1, we are finding the value of y. So just substitute, because they've said x is what? Is equals to 1. So y is equals to 4x to the power 3 plus, that is x squared. So x squared plus 4x minus 3. So we just substitute. That is step 1. So y will be equal to, that is 1 squared plus 4 multiplied by 1 minus 3. So this is 1 plus 4 minus 3. This one will give us 5 minus 3, and the value here will be 2. That is step 1. You have found. Then step 2. Step 2. Now you find the gradient. Find the gradient. Okay? So step 2, you are finding the gradient. Remember the gradient function? So to find the gradient, we first of all have to find dy by dx of this one. So dy by dx will simply be equal to, the 2 comes down here, we are going to have 2x plus, then this one here, it will be -1. This one will just be 1, so it will be +4. Remember what we learned? Because this is 1, we bring it down. 1 times 4 is 4. Then this one will remain to the power 0. Anything to the power 0 is 1. So that is how come we're finding 4. Then also remember the derivative of a constant number is 0. So we just ignore it. So the dy by dx is this one. Then we know that dy by dx is equals to gradient. So for us to find the gradient m here, we are simply going to now substitute. Okay? We substitute. We put 2, we put 1 there, plus 4. So this one will simply be equal to 2 plus 4, and our gradient here will be 6. Okay, so we proceed. Now that we have our gradient, and remember we said gradient of the tangent is known as m1. So we have found our m1. Now we can find the equation now. Step 3, which is the final step here, we now find the equation. So we find the equation by substituting. Okay, find the equation by substituting. Okay, so we are saying by substituting the found values into the equation. So into the equation, m is equals to y2 minus y1 over x2 minus x1. You remember this one? So we continue. Our gradient now is 6, so it will be 6 is equals to our y2 we don't know. We only have one set of coordinates, because after we found the value of y2 here, we had a set of coordinate now here, which will be 1, 2. So this is the reason why we are finding this one. So we have this set, which is the x1, y1, but y2 and x2 we don't have. So y minus, so that one is the minus 2 over 1 over x minus 1. Then there we can cross multiply. So this is 1 multiplying with y minus 2, which is equals to 6 multiplying with x minus 1. So this is y minus 2 is equals to 6x minus 6. Then this one here will be y is equals to 6x minus 6 plus 2, because this one crosses. So y will be equal to 6x minus 4. And we have found the equation. So the equation, always y has to be the subject of the formula. Okay, so as we are still doing this one, let's look at also the steps for determining the gradient of, for determining the equation of the normal. So determining the equation of the normal, also it follows almost the same steps, except that this one, it has been simplified into 4 steps so that you can easily master them and apply them appropriately. Okay, so also here, step 1, when you are determining the equation of the normal, step 1 here, it's one and the same thing like we did in the previous. So step 1, we are simply going to also find the value of y. So find y. So we are going to write y is equals to 4x to the power 3 plus x plus 1. Okay, then this one will be y is equals to 4. We put our value, which is negative 1 to the power 3 plus, so negative 1 plus 1. Okay, so y is equals to, so this negative 1 to the power 3, it is still negative 1 and negative 1. So times this 4, it will still be negative 4. Okay, then this one and this one will be negative 1 plus 1. So it is as good as these are cancelling each other. So y is equals to negative 4. This implies that we now have the coordinates, which is negative 1, negative 4. Okay, so we proceed to step 2. So proceeding to step 2 now here is now where we are saying we want to find the gradient. So to find the gradient now, listen, we said m1 is the gradient for the tangent, but here what we want is for the normal. And so to find the gradient of the normal, you first of all have to find the gradient of the tangent. Then you use that relationship which we discussed. So the first thing here, we find the gradient of the tangent. So find m for the tangent. So find the m1, which is for the tangent. So also we say dy by dx is equals to m, which is equals to, so that equation there, we are going to go straight forward. The 3 comes down. We are going to have 12x squared plus, so this is the 1, and it ends there, because 1 minus 1 will give us 0. Anything to the power 0 is 1. So that is to find the gradient, we put the value of x. So it will be 12 multiplied by negative 1 squared plus 1. So which will be 12 plus 1, which is equals to 13. Okay. So now after we find this one, we can proceed and also say maybe step 3. We also find now, we find m2. So finding m2, we are simply going to say m1 m2 is equals to -1 because that is the relationship between the two. So this one will be 13 m2 is equals to -1. Then we know that m2 here will be equal to, because we divide by 13, we also divide by 13, will be equal to -1 over 13. So that is our m2. Okay, so we proceed now. We continue to the next step. Okay, so in the next step, we are going to now substitute what we have found. Okay, so this is step 2. So we go to step 3. So in step 3, now we have the coordinates, we have our gradient. So the next thing that we have now is to substitute into the equation like we did before. So the equation is m is equals to y2 minus y1 over x2 minus x1. So substituting into this one now, we are going to say, okay, we have the gradient, which is -1 over 13 being equal to, okay, y2 we don't have, so it will remain y, minus, then y1, we check our y1, which is -4, okay, over x we don't have, then we have the xy, which is -1, so that's what we have. So this one will be -1 over 13 being equal to y plus 4 over this, and that is plus, so over x plus 1. Okay, then here it means we cross multiply, so we are multiplying, this is 13 multiplying with y plus 4, which should be equal to -1 multiplying with x plus 1. So this one we have 13y, then plus 53, okay, yeah, so plus 50, so 13 times 4, let's do this one, 13 times 4, this is 12, okay, we have 52, so this is 52, which is equals to -x, -1. So we group the like terms because y has to be on its own, so it will be 13y is equals to -x, -1, -52. So this one will be 13y is equals to -x, -53. So divided by 13, divided by 13, divided by 13. This one and that one goes. So here we have y is equals to -1 over 13x, then minus, so this one into that one, it goes there 4 times, leaving a remainder 1 over 13. And this is how we determine the gradient of the normal. So quickly for a summary, I'm sure you would have noticed something. It is very important that we know the relationship m1 times m2 will give us -1, because it is going to be used all the time when you want to find the gradient of the normal. So step 1, find the gradient of the what? After you find the points here, then you have to find the gradient of the tangent. After you find and use the gradient of the tangent to find the gradient of the normal, which is m2. Then having found that, you just have to substitute into this equation and you are done. So that is how we find the equation of the tangent and the equation of the normal. For any questions, any queries, I'll be on standby. Thank you.